Hello everyone, welcome to the channel. Here's another GCSE exam style question on physics. Please pause the video and give this a try. So you can see it's a 4-mark question. So you need to have a minimum of 4 points. Write your answer and then press play and you can compare your answer with mine. The national grid uses very high voltages to transmit electricity over long distances. Explain why using a high voltage is more efficient for transmitting electricity. So here's the power station. It produces electricity. So we use these transformers to increase the voltage to a very high value, like sometimes to about 400,000 volts, really high voltage. And then you transmit this to wherever you want to take it. And near like the consumers in local substations, we use step-down transformers to reduce it, and the customers usually get 230 volts. Now the question is, why do we use such high voltages? What's the point? Now, I'm going to get the mark scheme points, what you would get for each one. But before that, let me explain you a few things. Now, the formula for electrical power is P is equal to I multiplied by V. P is equal to IV. So I here is the current, P is the power, V is the voltage. Now let me use some random values so you'll see what I mean by this. Now let's say the power is 1000 watts. Now, for a given value of power, because P is equal to IV, let's say if I is 2, power is 1000. Obviously, what's V now? V must be 2 times something, 500. However, if I increase the voltage to a high value, now let's say I'm going to increase the voltage to 1000. Now what will happen? So the current is only 1 amp. Now let's say you increase the voltage to 2000. Now what will happen? So power is 1000. Something multiplied by 2000 is 1000. That's obviously 0.5. Now, look at the voltage values. 500, you doubled it, 1000, you double that one again, 2000. And let's look at the current values. 2, 1, 0.5. So you can clearly see the higher the voltage, the lower the current. So, in the national grid, when we use a really high voltage, obviously what that means is the current is significantly low. So how does a low current help us? Well, that's because the power dissipation in the cables is I squared R. So if I have a low current, obviously power will be less, meaning the energy or the power dissipation by these, the energy that goes out by it in terms of heat is less. So let's put this into a nice answer now. So here's how you can put this into words. Using a high voltage reduces the current in the transmission cables. That's the first point about this. Next one. Lower current means less energy is lost as heat due to resistance in the wires. So this is because P is equal to I squared R. So low current means less power. This makes the transmission of electricity more efficient. More efficient is a keyword. Transformers are used to increase the voltage before transmission, step up transformers, and decrease it before use step down transformers. So that will get you full marks.